seen that hydrogen gas is very light and so rises in the atmosphere. Have you ever wondered how hydrogen is obtained? Hydrogen can be prepared from compounds like water, acids and bases, as they all contain hydrogen. Highly reactive metals like potassium, sodium and calcium, when exposed to cold water, liberate hydrogen along with energy. Hence, these reactions are exothermic in nature. For example, potassium reacts with water to produce potassium hydroxide and hydrogen. However, this method is not preferred because the exothermic reaction is very violent in nature and the heat liberated ignites hydrogen as well. Sodium also reacts with water to produce sodium hydroxide and hydrogen. This is also not a preferred method as the reaction is violent, though less than that with potassium. Another reason for avoiding this method is that the collection of hydrogen becomes difficult as sodium melts into a globule and moves randomly on the surface of water. Calcium also reacts with water to produce calcium hydroxide and hydrogen. However, calcium being an expensive metal is generally not used to obtain hydrogen. Other metals such as magnesium, aluminium, zinc and iron do not react with cold water to liberate hydrogen. However, it is possible to obtain hydrogen from magnesium by boiling it with water. This reaction takes time. Magnesium reacts with boiling water to produce magnesium hydroxide and hydrogen gas. Less reactive metals such as magnesium, aluminium, zinc and iron react with steam to liberate hydrogen. Of all these metals, the rate of reaction of magnesium is the fastest. Magnesium reacts with steam to produce magnesium oxide and hydrogen. Aluminium reacts with the oxygen in the air to form a coat of aluminium oxide. Therefore, it is important to remove the coating by rubbing with sandpaper before you get it to react with steam. The rate of this reaction is slower than that of magnesium. Aluminium reacts with steam to produce aluminium oxide and hydrogen. Zinc reacts with steam to form zinc oxide and reduces water to hydrogen. It is possible to obtain hydrogen from iron only when it is red hot. Iron reacts with steam to produce ferric oxide and hydrogen. It is important to know that the oxides of magnesium, aluminium and zinc form on the surface of these metals when they react with steam. The formation of these oxides block the contact of steam with the metals, and therefore the reactions do not continue for long. Now, you will see another way of preparing hydrogen, the action of acids on metals. A metal that is more reactive than hydrogen reacts with an acid to liberate hydrogen. Reaction with sodium, potassium and calcium is violent, while the reaction with zinc, iron, aluminium and magnesium is smooth. Sodium reacts with dilute hydrochloric acid to give sodium chloride and hydrogen. Similarly, potassium reacts with dilute hydrochloric acid to give potassium chloride and hydrogen. Calcium reacts with dilute hydrochloric acid to give calcium chloride and hydrogen. Zinc reacts with dilute hydrochloric acid to give zinc chloride and hydrogen. Iron reacts with dilute hydrochloric acid to give ferrous chloride and hydrogen. Aluminium reacts with dilute sulfuric acid to give aluminium sulfate and hydrogen. Magnesium reacts with dilute hydrochloric acid to give magnesium chloride and hydrogen. The rate of reaction of these metals determines the activity series of metals. Potassium, sodium, and calcium displace hydrogen from acids with explosive violence. Magnesium, aluminium, and zinc displace hydrogen from acids vigorously but not violently. Iron, nickel, and tin displace hydrogen from acids gently. Lead displaces hydrogen from only hot concentrated acids. The position of hydrogen in the activity series comes after lead. Copper, mercury, silver, platinum, and gold do not displace hydrogen from acids at all. There are some important things that you need to remember regarding the activity series of metals. The most reactive metals are placed near the top of the activity series, and the reactivity decreases as you go down the series. A more reactive element can displace a less reactive element from its salt solution. The metals above hydrogen in the activity series react with dilute sulfuric acid and dilute hydrochloric acid to liberate hydrogen. The metals below hydrogen in the activity series cannot do that. The action of acids on metals is not the only way to obtain hydrogen from metals. You will now learn about the preparation of hydrogen by the action of alkalis on metals. There are certain metals that liberate hydrogen when they are boiled with concentrated alkali solutions. For example, aluminium reacts with sodium hydroxide and water to produce sodium meta-aluminate and hydrogen. Zinc reacts with sodium hydroxide to form sodium zincate and hydrogen. Tin reacts with sodium hydroxide and water to form sodium stannate and hydrogen. The standard ways for producing hydrogen inside a laboratory, however, are by the action of dilute sulfuric acid or dilute hydrochloric acid on zinc granules. Let's see the procedure. Place granulated zinc in a wide-mouthed, flat-bottomed flask. Fix a 2-holed rubber cork to the flask. Insert a thistle funnel through one hole and a delivery tube through the other. Connect the other end of the delivery tube to a beehive shelf placed under water in a trough. Add dilute sulfuric acid drop by drop from the thistle funnel. You will observe the effervescence of gas in the form of bubbles in the water as sulfuric acid reacts with the zinc granules. Collect the gas by the downward displacement of water. You must take a few precautions while preparing hydrogen using this procedure. Do not bring any flame close to the apparatus in which hydrogen is being generated. Ensure that the bottom of the thistle funnel is dipped in the acid so as to prevent the gas from escaping through the thistle funnel.